So this video is going to look at some examples of mathematical simulation software. And so I'm going to start with Geogebra, which is a dynamic geometry software, and it is completely free. It is a free open source version of like Geometry Sketchpad. And I'm going to start by looking at some geometry examples, but it does do some algebra, graphing type things as well. So the benefit of GeoGebra, right now I'm using the Chrome app, but it can also be downloaded as a free program. So there's various formats of GeoGebra. So we have all these tools here. It's basically like having geometric constructions at your fingertips, with the technology to be able to stretch things and change things, and it allows students to be able to see the patterns that are happening within shapes and lines and segments and such. Okay, so we have all these different tools, and I'll just show you an example of, for example, creating a parallelogram, for example. So I did this recently with my students. I showed them how we can create a parallelogram by its definition. So it's defined as a four-sided shape that has two pairs of opposite sides that are parallel. So I create a segment as one side, and then I use the parallel line tool to create a parallel line to this given segment here. And then I can use the parallel line tool again. Well, before I do that, let's connect a segment here from A to C, the point I just made here. So then I can create another parallel line that's parallel to this side and goes through this point. And then I teach them how you can use the intersecting tool to get this point right here where it's made. So then I can show them that it will always be a parallelogram. And if I want to clean it up, I can go ahead and go over it with the polygon tool, picking those 4 points that were constructed in a way so that they always make a parallelogram. Then I can hide these other things. I can make them go away so that I don't have to look at sort of the extra lines. So now I have this beautiful parallelogram that will stay a parallelogram no matter what I do with the points. So I can show them the different iterations of parallelograms based on how these points are moving. And so it allows things that you just can't do on paper. So then we can start investigating a parallelogram. We can measure angles by picking the vertices of the angles, and then we can compare them. So then we can compare that angle to this angle and see that the opposite angles are congruent. I can get all the angles and figure out that we can discuss how these are supplementary and why they're supplementary. We can look at the side lengths. So I can click on A and C and it'll tell me what AC is. And then I can click on B and D and look at that it's 10.27. But the really powerful thing is, instead of just giving like a paper copy of a parallelogram and having them measure these things, what the technology allows you to do is still move the points and see that these ideas that opposite angles and opposite sides are congruent are holding despite the fact that I'm changing the points. So it's not just a one-time case, it works in general. So that's one example of how you can simulate the construction of geometry to sort of help students understand the theorems behind them.